Welcome back to Geometry. This is your teacher, Mr. O'Shea. Today we're going to be talking about 1.4 as well as 1.5. So it might be a little longer today, but it'll pay off. 1.4 is all about measuring angles. We're going to pick back up on measuring angles where we left off of the last lesson. And 1.5, we're going to get into this idea of perpendicular as well as angle bisectors. So we got kind of hodgepodge of three different topics, but they all kind of blend together for these two lessons. We're going to start off talking about an angle. And what an angle is, the proper definition is two rays with a common endpoint. So it's two rays with a common endpoint. Now, this might sound like opposite rays. The only difference here is that these two rays can go in any direction, and that would be your angle. Alright, so naming angles. Got a couple of different ways to do this, and I know I said name the angle in two different ways, but we're actually going to name each angle in a whole bunch of different ways. So this first one that I'm highlighting is angle from, if I made A to B to C. We're going to call that angle A, B, C. It's really how would you draw it when you actually made it out with your pen. I started at A, I went to B, and then I went to C, so that's how I'm actually going to go ahead and name it. Now we could also go backwards and go C to B to A. So that could be angle C, B, A. Now a third way you can name this one is just by calling it angle 1. Now if you've seen there, the 1 is inside that angle. That's the only angle it could reference, so we can go ahead and name that one angle 1. Now the second one, let's do it in green. It's going to go from C to B, so that's ray BC, and ray BD are the two rays that make that one up. See, that's C or BC and BD. So we're going to call that angle CBD, starting at C down to B to D. Or we could do it backwards and call it angle DBC, starting at D, going to B and then up to C, that's fine. Or we can go ahead and name that one angle 2. Again, the same reason. That 2 is inside that angle. It only refers to that one. Now there's a third one we have to name. Now if we went from A and went all the way over there to D, it's that big angle that makes it up. So we go from A down there to B, so that's ray BA, and ray BD makes up another angle. We're going to call that one angle ABD or angle DBA if we went the other way, right? Started at D to B to A. So that's angle DBA. Now we can also name this one. Now we name the first one angle 1, angle 2. We can name this one angle B because that's the center point. Okay. Another name for those is actually going to be called the vertex. Now if you guys notice B, 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 that B is inside all of these angles. And the B is that middle piece of all of the angles. We're going to go ahead and call that the vertex. It's the corner of the angle. You can think of vertex as the corner. Alright, types of angles. We got 4 of them. The first one, hopefully this is a review, is just acute angles. And acute angles typically are smaller angles. They range anywhere from 0 to 90 degrees. We measure angles with degrees. 360 degrees in a full circle, so these are just portions of a circle. Your next one that we're going to cover is a right angle. And right angles are exactly 90 degrees. They must be 90 degrees. See this little box there that we drew in there? That's going to be the symbol. Anytime you see that, you can automatically think 90 degrees. Alright, our third one that we're dealing with here, it's a little bit bigger. That one's going to be called an obtuse angle. And obtuse angles are bigger than 90 degrees, but they are less than 180 degrees. So it's anywhere between 90 and 180 degrees. And we've got our last one here, and that doesn't even look like an angle, but it is. It's two rays that share a common endpoint. That one is going to be called a straight angle. We also referred to these as opposite rays before. Straight angles are always 180 degrees. the idea of straight, meaning 180. That's going to come into play a lot in geometry this year. We've got postulate 1-8. Postulate 1-8 states that if point B is in the interior, so if point B is in the interior of angle ADC, then the measure, notice that little m there, I put it in front of the angle, that's talking about the measure of angle ADB, plus the measure of angle BDC equals the measure of angle ADC. What in the world does all that mean? Well, it's going to help us out a lot if we can go ahead and draw that picture. So let's do that now. I'm going to cheat and use some straight lines here. Go ahead and make those the best you can. Let's make that A, and D, and C. We said that B is somewhere on the interior of that. So somewhere inside here, let's just go ahead and plop B right there. All right, and I can connect that array DB. There we go, perfect. All right, I know that the measure of angle ADB, let's highlight that one, A down to D to B, so that angle that I just drew out right there, that measurement plus the measure of BDC, so B down to D and C. So we've got the blue angle plus the red angle. That's going to equal the measure of angle ADC. So if I went from A to D to C, which is really just that big angle, which makes sense. The blue piece plus the red piece should equal the white one in there. All right, much easier way to remember this, you guys. This is also going to be commonly referred to as the angle addition postulate. You can write this right underneath postulate 1-8. In fact, if you wanted to cross out postulate 1-8 and just call it angle addition postulate, that's perfectly fine. And the gist of it is that you add the two small angles. So add the two smaller angles together to get the measure of the larger angle. Okay, that's the postulate 1-8, kind of a little easier. Here's an example of it. Find the angle measure. What's the measure of angle TSW if the measure of RST is 50 and RSW is 125? So we're going TSW, we're looking for that angle. We don't know what it is. But we do know that angle RST, that one is 50 degrees. And RSW, let's do that one red, RSW, that's the big one. That big angle is 125 degrees. Okay. Well, I know the two small ones have to add up to be the big one. So 50. So RST, let's go and actually write it out. The measure of RST plus the measure of TSW has to equal the bigger angle. So that's the measure of angle RSW. All right, RST is really 50 degrees. We don't know TSW, so let's use X. And the big angle is 125. Just a quick, easy equation that we can go ahead and solve. Subtract 50 on both sides. And we get that X equals 75. Which really means that the measure of angle TSW equals 75 degrees. 50 plus the 75 would equal that full 125. All right, solve for x. If the measure of RQS is 2x plus 4 and TQS is 6x plus 20, What is RQS? What is TQS? Show how you can check your work. All right, this idea of straight angles, you guys, this is going to be a huge one. Anytime you can make a straight line, like we just did, you always have to think 180. Okay, so we've got RQS, which is 2x plus 4, and we've got SQT, that other section, which is 6x plus 20. Anytime we have a straight angle, we can always add those angles up, and they must equal, straight angles, 180 degrees. All right, let's go ahead and do a quick algebra here. 6x and 2x is going to give us 8x plus 4 and 20 is 24. We got 8x plus 24 equals 180. Let's subtract 24 on both sides here. We're left with 8x equals 156. We will divide each side by 8. And we're left with x equals 19.5. Okay. Unfortunately, that's just the first part of our problem. So now we have to use that to find the measure of RQS, which is this angle right there in yellow. And that's 2x plus 4. So I'm just going to substitute it in 2x, but instead of x, we'll use 19.5 plus 4. That's going to equal 43 degrees. All right, and the next one we have to find is TQS, which is that white angle right there, and that's 6x plus 20. So 6 times x, which is 19.5, plus 20, it's going to give us 137 degrees. Now, hopefully you guys are kind of looking at this problem and realizing that obviously our numbers are off, or our picture is off, because how in the world can the obtuse angle be 43 degrees and the acute angle be 137 degrees? What I need you guys to realize is that sometimes diagrams are off, and that's okay. We just need to worry about how the actual numbers add up. So in this picture, it's okay that the diagram is off. Don't worry about it too much when we're doing these. All right, so the big thing is, how do you check our answer? Well, like we had said before, we definitely know that it's a straight angle, so it has to add up to 180. So I'm just going to add those two angles up, 43 plus 137. And that does in fact add up to 180, so we are all good with this problem. All right, congruent angles. Let me keep plowing through here. Congruent angles are angles with, you guessed it, the same measure. Okay, so if this angle over here, call it ABC, and we'll give another angle over here, and they don't have to face in the same direction, so these two are kind of opened in different ways, but that's okay, WX, Y. As long as they're both the same measure, let's say that's about 15 degrees, and that's also 15 degrees, then they are congruent. So angle ABC is congruent to, remember that sign congruent, that means equals, congruent to angle WXY. They're both 15 degrees. All right, find each angle measure. The measure of AOB is 4x minus 2, BOC is 5x plus 10, and COD is 2x plus 14. Unfortunately, we don't have anything except these little tick marks here. Those are key. Those little tick marks mean that the measure of angle AOB, which is the first green tick mark, and COD are congruent. Okay, anytime you guys have tick marks on your diagram, you must look for them because they signal which angles are actually congruent to each other. So in this case, the fact that AOB and COD both have tick marks, that tells me they're congruent. Now in that middle angle, you guys notice that angle BOC does not have any tick marks. That means that it could be a different measurement, so we don't actually know too much about that. But the fact that AOB right here and COD right here have the tick marks, that's how we can actually go ahead and tell that they are congruent. All right, congruent means equals, so AOB is 4x minus 2, so we got 4x minus 2, and that equals COD. COD is 2x plus 14. Do the quick algebra on this. We're going to subtract 2x on both sides. I get 2x, and I'll add 2 to both sides to cancel that. 2x equals 16. We're going to divide each side by 2, and we get x equals 8. All right, didn't solve our problem yet, because we got to actually go ahead and find the angle measurements. So we're going to start with the first one, AOB. That is the measure of angle AOB. Gotta have the M out in front to talk about measurement. That's 4x minus 2, so that's 4 times 8 minus 2, which is going to give us 30 degrees. 30. Now we're going to move on to that middle one, BOC. Oh, you know what? Hang on, I don't want to use just one tick mark, right? Because that means congruent, so let's go ahead and make 2 tick marks. Now that tells me that those are not congruent. All right, BOC is 5x plus 10. 5 times 8 plus 10 is 50 degrees, so that middle one is 50. Now COD. COD should be 30, right, because it's congruent, but we're going to test it anyways. COD is 2 times 8 plus 14, which equals 30. Oh, good. Now we know that our answers are correct because those two angles were congruent, right? And we have one last one. Can always talk about that big angle, guys. AOD, large angle. And that just is all the interior angles added up. So that's 30 plus 50 plus 30, all the inside ones, which is 110 degrees. All right, perpendicular lines. Perpendicular lines are two lines that intersect each other. So two lines that intersect to form right angles. I'm going to abbreviate angles like that. Oh, two lines, they cross, and where they cross, they make 90-degree angles. We're going to use a symbol for it. The symbol looks like an upside-down T. That's going to be the symbol. Anytime you see it, you have perpendicular. Perpendicular bisector. We're going to add a level onto this. It's a line, a ray, or even a segment that is, let's use the symbol, perpendicular. Remember, perpendicular, that's a symbol for it. Perpendicular to a segment, has to be a segment. So it's a line, a ray, or a segment that's perpendicular to a segment at its midpoint. It's going to make a lot more sense if we actually draw this out. So we've got a line, and what this line does, it's perpendicular to a segment. So the segment has to be a fixed length. Perpendicular meaning that it crosses at 90 degrees. And at its midpoint tells me that it actually cuts that segment into two equal parts. And now I use those tick lines on there telling me that this left side is equal to the right side because this center point would be its midpoint. Angle bisector. Just same idea with the bisector. It's a ray that divides an angle into two congruent angles. All right, let's use this idea of angle bisectors and all that. Bisects, anytime you guys see the word bisect, bisects, you should be thinking bi like bicycle. Bicycle has two wheels. Bisect means it cuts it into two equal parts. I always think bisect, two equal parts. All right, so we've got Kn bisects angle JKL, so that the measure of JKL is 5x minus 25, and the measure of NKL is 3x plus 5. Solve for x and find the measure of JKN. Okay. Now the fact that Kn bisects it tells me that these two angles have to be congruent. Kn is the bisector. It splits the angles into two equal ones. So I know that JKL has to be congruent to angle JKL is congruent to angle NKL. And we can also tell that based on the symbols that are in the picture. So JKL is 5x minus 25 equals 3x plus 5, Let's do the quick algebra. That's going to leave us with 2x equals 30. I brought the 3x over and the 25 over. Divide each side by 2, I get x equals 15. Alright, so I solve for x. Which means that angle JKN is 5x minus 25, but we're going to substitute that in as 5 times 15 minus 25. Leaves us a total of 50 degrees. So the measure of angle JKN is 50 degrees. And the last one. We've got line LK is the perpendicular bisector of segment TN, perpendicular bisector. The intersection of line LK and TN is F. TN is 14. What is TF? Draw a picture and solve. It's always handy to draw pictures, guys, when you don't actually have it. I'm going to cheat here and use the straight line tool. Alright, so I've got two lines that intersect. Let's go and call this one TN. This is going to be our segment. That's segment TN. And LK is a line, so I got to put my line symbols on there. LK. It's a perpendicular bisector, so I know it's 90 degrees. That section and those two sections have to be equal because it cut it at its midpoint. And the intersection is F. Alright, so I think I drew my picture out perfect. Okay, we know that TN, the length of TN, from T to N, is 14. Based on the fact that LK is a perpendicular bisector, we can find TF. Now, TF has to then be half of the 14. Those two little lines mean that I cut it in half. So, what is half of 14? Well, that's just 7. So that tells me that TF is in fact 7, half of the full length. Alright guys, make sure you have all of the check yourself problems done for class. If you have any questions, please go back, rewind, check some of the video out again, write down your questions and have them ready for class. See you guys tomorrow.